Okay, here are your solutions to 5-2. These are the examples. First thing I would like you to do is put a little bit about this in your notes, the proof process. The big thing you probably ought to have here is this flow chart here. And basically what I want you to understand about this is you'll be doing a lot of this when you were in geometry in high school, where you take something that you know and then you prove that you can extend that knowledge to something new. Okay, so in this case, the proof process, step one is list the given information, so we want to focus on givens, or what we already know, and then think about or state what we're going to try to prove. That is our hypothesis, just like in science. And then step three, create a deductive argument by forming a logical chain. This is what this is all about, a chain of statements linking the given information to what you're trying to prove. So we've got statements and reasons. And then step four is justify each statement with a reason. Reasons include definitions, algebraic properties, and theorems. So there's some things that we know to be true about mathematics, and we could use those in order to extend something that we are given in order to prove something new, come to a new conclusion. Let's take a look at what this means. First of all, some things you ought to put immediately in your notes. 3 new vocabulary words here. A proof is a logical argument where each statement is justified by a reason. A paragraph proof is also known as an informal proof. It involves writing a paragraph to explain why a conjecture is true. In example 1 below, you will use the algebraic property of substitution and the geometric relationship between vertical angles. So let's take a look at what some of this might mean. In problem number 1, the diamondback rattlesnake has a diamond pattern on its back. You can see that right here. An enlargement of the skin is shown. If angle 1 equals angle 4, write a paragraph proof to show that angle 2 has to equal angle 3. Well, first of all, we're going to state what's given. We're going to state that angle 1 and angle 4 are the same. Then you're going to prove that the measure of angle 2 equals the measure of angle 3. That's what we need to prove. So here comes the proof. First of all, you can say, and let's back up here a little bit. First of all, you can say that the measure of angle 1 has to equal the measure of angle 2. You can say that because they're vertical. So we have 1 equaling 2. Then, since 1 equals 4, remember we were given that, since 1 equals 4, we can substitute and say that 2 equals 4. So now we're to the point where we say that 2 equals 4 because we have substitution. Then the measure of angle 4 has to equal 3 because they are vertical angles. So these two are equal because they're vertical. Since the measure of angle 2 equals the measure of angle 4, then the measure of angle 2 equals angle 3 by substitution. Therefore, the measure of angle 2 equals 3. So let's take this one more time through this. We can show that measure of angle 1 is the same as angle 2 because they're vertical. We can show that the measure of angle 1 equals 4 because the measure of angle 2 was given to be 4. And then we can look at the measure of angle 4 is equal to 3 also because they're vertical. Therefore, you can show that the measure of angle 2 has to equal the measure of angle 3 by substitution. Therefore, 2 equals 3. I would suggest you take a little bit of time and go through that step by step and make sure you follow that. Please press pause and do letter A. Once again, we've got something to add to our gold sheet and our notes. 3 new vocabulary words. We have a 2-column proof or formal proof. Contains statements and reasons organized in 2 columns. Once a statement or conjecture has been proven, it's called a theorem, and it can be used as a reason to justify statements in other proofs. So again, let's take a look at what that might mean. So we have example 2. Write a 2-column proof to show that if 2 angles are vertical angles, then they have the same measure. Given lines M and N intersect, angle 1 and 3 are vertical angles. So we've got 1 and 3 being vertical angles. Prove that angle 1 equals angle 3. Okay, so the first thing we can do is take a look at lines M and N intersect. That's a given. Okay, so therefore those two are vertical angles. That's all given. Now we can have angle 1. Let's do this in green. We can have angle 1 and angle 2 are a linear pair, and angle 3 and 2 are also a linear pair. 3 and 2 are a linear pair. What a linear pair means is that they are on a single line, and therefore they equal 180 degrees. So we can make a couple of statements here. We can say that the measure of angle 1 and 2, right there, 1 and 2 are 180 degrees. That's the definition of supplementary angles. Because they're a linear pair, they lie on the same line. Okay? Then we can also say, so that was 1 and 2, we can also say that 3 and 2 equal 180 degrees. So now we have 3 and 2 equaling 180 degrees. So we have the measure of angle 1 plus the measure of angle 2 is 180 degrees, and the measure of angle 3 plus 2 is 180 degrees. Therefore, we can say that the measure of angle 1 and angle 2 equals the measure of angle 3 and angle 2. Because basically we have, let's color code this. I'm going to back this up. Basically what we have the measure of angle 1 and 2 equal 180 degrees. So we have 180 degrees. And we also have 180 degrees is equal to the measure of angles 3 and 2. Therefore, if the purple here equals red, or 180 degrees, and the blue also equals 180 degrees, then basically what you can show is that purple and blue have to equal each other. So let's take a look at that. So we had purple and blue must equal each other, because this right here was the purple and this right here was the blue. And they're both equal to 180, so they must be equal to each other. So now we could subtract, so that was by substitution. We're substituting this for the 180 degrees in one of those two. Then you can say if measure of angle 1 plus the measure of angle 2 equals the measure of angle 3 plus the measure of angle 2, what we could do is subtract 2 from both sides, and understand I'm subtracting the measure of angle 2 from both sides. I'm getting rid of that and getting rid of that, and I end up with the measure of angle 1 equals the measure of angle 3. And that's what we're looking for when we do these proofs. Please press pause and do letter B. Keep in mind that what I want you to learn from this is to get used to these proofs. You will learn a lot more about this in high school. I just want you to be generally familiar with this proof process, and that's why they give you the statements, and now what they want you to do is come up with the reasons. And remember, you can always use the letter videos in order to check and become more familiar with this.